we repeat the deformation pattern and directions of MZ. So the deformation pattern, I do apologize, okay? You asked that question 11 minutes ago. So if this is P and P prime, right? It's opening up, yes or no? Right? So it's opening up. That's why the deformation is in that direction. It's not pulling it in, right? So that's it. So in order to pull that way, right? MZ has to be in this, it has to rotate in this direction. Yes or no? Right? You pull and then you what? Rotate. Because the center is at the center, right? Then you pull, then you what? You rotate. Right? So MZ is in that direction. Okay. So when that's the case, then you can identify the tension and compression. So you, if you look at the way it's deformed, so the way it's deformed, the top down here, the circumference increases, right? So that's why this is in tensile mode, and then the one bottom is in what? Compression. Okay. I hope you are clear. Are you okay? Okay. I hope there's no saying that he's clear or not clear. I'm fine. Right. So if you decide to take at the bottom, right, to calculate this value over here will be what? 0.05, right? Then then we have to what? So 0.05. Then you have to plus the entire thickness, and then minus by 11 point what? 11.854, 11.846. Right? So this answer and this answer, it will be the same eventually. But if you forget to minus here or plus any of this, you're done. That is why I specify the datum taken from the what? From
top.
Yep, from the position of the acting force. Okay, for this reason, right? So you just do D is equal to 50, then E you just put E and you're good to go. Okay, you Bob's your uncle. Okay, okay. So I hope for a typical example like this, I'm saying this because over like close to 13 years of teaching this topic, this is one of the most common mistake. Okay, 13 years teaching this topic per year. I teach 3 times. 39 times I've been teaching this course, okay? And I hope I still have the same energy. Okay, so that's why you have to be really what? Careful. Okay. So now we're going to find stress X at point D now, right? So you have again Px over A. So this is straightforward. Then plus by Mz over. So it will not be plus, it will be under what? Compression now. So now it's minus Mz over Izz multiplied by Y. Okay, so the axial load is still the same, positive 3.846 times 10 to the power 6. Then this will be minus, same thing like before, 400 multiplied by 0.05 plus by 8.154 times 10 to the power minus 3, right? Then Y from the what? From the centroid, all right, to point D. Now this will be equal to 20 times 10 to the power minus 3 minus by 8.154 times 10 to the power minus 3. Okay, then the whole thing you divide by 3.8802 times 10 to the power minus 9. Okay. So this will be equal to 3.846 times 10 to the power 6 minus by 400 times by 0.05 plus 8.154 power minus 3 close bracket times by 20 power minus 3 minus 8.154 power minus 3 close bracket divide by 3.8802 power minus 9. I get 71.017. So it's 0.16 times 10 to the power 6. So this will be equal to 3.846 power 6 minus 71.016 power 6. So this will be equal to minus 67.17 times 10 to the power 6 Pascal. Okay. So what do we observe is, I want you to look at these two values now. Can anyone comment on this two magnitude for me, please? What do you observe? Anyone? What do you observe? Anyone? I will tell you, I'll give you a hint, okay? If I want to break this ruler, right? By the way, most of us have anger management issue. I'm one of those, okay? So looking at this ruler, if I'm going to break this ruler, right? I will like, doing it in Excel loading, is it difficult? Yes or no? It is difficult, right? So it's easier to break this ruler by how? Bending, am I right? Yes or no? When you bend, it's easier to what? Break the ruler, right? When you bend, it's so much easier to break the ruler than you stretch. So what can you conclude from this? Anyone? What can you conclude by this observation? It's not that we have anger management issue, but if something don't break axially, what do we tend to do? Anyone? Are you guys there? Or you're just there but you're not there? Anyone, please?
Yeah, you just try bending.
Yeah. You'll be a bend, right? So if you look at the what I've highlighted in yellow relative to pink, the stresses induced by bending is what? Higher than what? Axial loading.
Axial.
Yeah. So it's always the fact that the stresses induced by bending moment is higher than axial stress. Okay, so I'm going to highlight this in yellow, correspond to yellow, and this correspond to pink. It's always a fact. Yes, it's what you can see from our analysis. So the next thing that we're going to do part C. Okay, so part C. Okay, so part C is to find the position of the neutral axis. Okay, so for this case, for the neutral axis, right? For the neutral axis, stress X must be equal to what? Must be equal to 0. So if we were to use the formula where you have stress X is equal to Px over A minus by Mz over by Izz multiplied by what? Y. So when stress X is equal to 0, but you have to remember here that this is equal to minus, okay? right? So when that's the case, stress Z is equal to 0. Right? So at the neutral axis, so I call this equation 1. So when stress X is equal to 0, right? Equation 1 will become where you have 0 is equal to Px over A minus by Mz over Izz multiplied by Y. So you have Px over A, and this will be equal to Mz over Izz multiplied by Y, right? So you know that your Px over A, right? Your Px over A is equal to 3.846 times by 10 to power of 6, and this will be equal to your Mz. So your Mz over here again is equal to, I did not calculate the final value, how I wish I did. So this is equal to 400 multiplied by 0.05 plus by 8.154, then divide by 3 point, wait, what is the 3.8802 times 10 to the power minus 9. So it's the Y location that you want to look for now, okay? So this is equal to 400 times by 0.05 plus by 8.154 power of minus 3, close bracket, okay? So 3.846 power 6 divided by the moment times by 3.8802 power minus 9. My Y is equal to 6 point or 0.6415 times 10 to the power minus 3 meter. Okay, so we realize that Y is positive down here. Okay, so when Y is positive, if you come back over here, based on this is the position of the center of curvature, right? When that's the case, in this direction, oh, this is going to look real messy. In this direction that I'll show you over here, Y is positive, and in the opposite direction from the center of curvature, Y is negative. So from here, right, based on the center of curvature, from here we realize that Y positive means Y has been shifted, or the neutral axis is located below the what? Centroid. Okay. So now I'm going to teach you an easier way, okay, to actually visualize this better. Right now, by knowing whether is it upwards or downwards is relative to what? Relative to center of curvature, right? So it's positive. Y is positive downwards because if the bending is in this direction, right, the center of curvature is at the bottom. So when that's the case, positive is going to be Y positive downwards, Y negative upwards. So I think I did mention this last week, did I? All right. Oh, maybe not. Maybe I did not mention about this last week. Wait, let me see. Did I mention this last week? No. Okay, so y'all will not know the center of curve. Is it the one before last? let me see. Yeah, okay. So you all have seen this, the center of curvature. So you guys will know this, okay? But if not, there's I want you all to like visualize differently also. So like how I taught you guys shearing force, right? We have 5 rules or 4 rules that we make.